Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back in the lecture 5. Our topic is dark reaction, which is the second the most important part of the photosynthetic mechanism. The dark reaction is also called as Kelvin cycle because it is discovered by Melvin Kelvin and his colleagues in University of California. He got Nobel Prize in 1961 on the discovery of the Kelvin cycle. Dear students, this is called as the dark reaction because it is a light independent process. Light is not needed here. And it occurs in stroma part of the chloroplast. Dear students, you know very well about the grana and stroma part, but let me to recall your memory. This is grana part, thylakoid membrane, and this called stroma. So usually the dark reaction occur in the stroma part of the chloroplast. Now let me start. First I will make the cycle and then I will explain it. Dear students, 3 molecules of the carbon dioxide. The carbon dioxide in the photosynthesis will enter in the dark reaction. It have no role in the light reaction. The 3 molecules of carbon dioxide will combine with 5 carbon, 3 molecules of 5 carbon, and the name of this compound is called RUBP, ribulose bisphosphate. And the very popular enzyme Robisco catalyzes this process. Robisco is the enzyme which catalyzes the reaction between the carbon dioxide and RUBP, and a very unstable 6 carbon molecule is formed. 3 molecules of 6 carbons are formed. Because 3 molecules of carbon dioxide, we have 3 molecules of 5 carbon RUBP molecules we have. So we get 3 molecules of an unstable 6 carbon compound, which soon break up into 3 carbon compound. 6 molecules we get, because if we have 6 carbon 3 molecules, here we get 3 carbon 6 molecules, and the product of the light reaction. Dear students, you know very well what was the product of the light reaction. The product of the light reaction was ATP, which is converted into ADP here, plus PI means inorganic phosphate, and NADPH, which convert into NADP. And these 3 3-carbon molecule is called pGAL or PGAL phosphoglyceroldehyde. In this cycle, one molecule of PGAL, which is a 3-carbon molecule, get out from this cycle and will form the glucose. How it will form the glucose, let me tell you. And the 5 molecules of PGAL, remaining 5 molecules of PGAL, once again PGAL is a 3-carbon molecule, will regenerate the RUBP or the ribulose bisphosphate. 3 molecules of 5-carbon RUBP will be regenerated. Dear students, actually, if we see the overall reaction, there are 6 molecules of carbon dioxide, 6 molecules of RUBP, 6 molecules of 6-carbon are formed, and 12 molecules of 3-carbon are formed, and 2 molecules of 3-carbon comes out and form glucose, because glucose is a 6-carbon compound. So 2 molecules of pGAL or PGAL combine to form the glucose, and the rest of the 10 molecules will form the 6 molecules of the RUBP. Here ATP is used, which is the product of the light reaction, and NADPH is used, which was the product of the light reaction. Dear students, we will. I want to clear this point that this cycle will operate twice to a glucose molecule is formed. I told you that this 3-carbon dioxide combined with 3 molecules of 5-carbon, but if you see the overall reaction, 6-carbon dioxide plus 12 H2O, then they form the glucose molecule. Glucose molecule is a 6C6H12O6. So the confusion arises in the minds of the students that how a 3-carbon pGAL molecule will come out from the cycle, how a 3-carbon molecule form a 6-carbon molecule. Dear student, if you multiply this whole figure with 2, or if you operate this whole process twice, or this Calvin cycle twice, you can get a glucose molecule. So the product of the dark reaction is the glucose molecule, and that glucose molecules is then converted into saccharose, which is a disaccharide sugar, and this saccharose then transported inside the plant through phloem, and if it is in excess, then they are stored in the form of starch, which is a polysaccharide. But the immediate product of the dark reaction is the glucose molecule. The glucose molecules are formed, and the glucose molecule then convert into the saccharose. I will explain it once more. It's a light-independent process. Light is not needed to initiate, or light have no particular role directly to start this process. That's why this is called light-independent process. It is also called a Calvin cycle. Melvin Calvin usually discovered it, and it occurs in the stroma part of the chloroplast. 3 molecules of carbon dioxide enter into a cycle, and already existing combined with an already existing compound called RUBP, ribulose bisphosphate, and 3 molecules of a 6-carbon compound is formed, which is a highly unstable compound. Soon it dissociates into 3-carbon compound, which is called pGAL. Because when we have 3 molecules of 6-carbon, so when they are split, we usually get 6 molecules of 3-carbon. The 1 molecule of pGAL, a 3-carbon molecule, will get out from the cycle and will participate in the formation of glucose. And the rest of 5 pGAL molecules will regenerate the RUBP. here, sorry, I want to add one point more. How many ATPs we need to operate this process? Usually we need 6 molecules of ATPs here. But when we regenerate 5 molecules, when we will regenerate RUBP3 molecules and 5 PGI molecules will contribute here, 3 molecules of ATPs again will be used. Why? Because this is ribulose bisphosphate or biphosphate. It has 2 phosphate, 1 phosphate, which this is one phosphate it got from this kind of phosphorylation. 1 phosphate it got from here, second phosphate it will get here. So 9 ATPs are found in the single carbon cycle. But when we will operate this, and we need to operate the carbon cycle twice, because for glucose molecule we need 2 pGal molecules, and 2 pGal molecules, 2 pGal molecules will combine to form a glucose molecule, because glucose is a 6-carbon compound. So overall 9 ATPs are used in one carbon cycle. If we operate it twice, so 9 2 is 18. Total 18 ATP utilization is needed to run the Calvin cycle, which is also called as the dark reaction. Hope that students you understand the concept of the dark reaction or the Calvin cycle. Now I am proceeding towards the different factors or the limiting factors which limits the process of photosynthesis. So let me start. Limiting factors of the photosynthesis. The limiting factors, the first limiting factor is the intensity of light. The intensity of light having direct relationship, directly proportional to the rate of photosynthesis. What does it mean? It means that if we reduce the intensity of sunlight, intensity of light, the rate of photosynthesis will decrease. If we increase the rate of the intensity of light, the rate of photosynthesis will also increase. Dear students, many students ask this question that only in the presence of sunlight the photosynthesis will happen. So I want to clarify this point, that in the presence of any light, photosynthesis can occur, because only the sunlight is not compulsory. And there are 2 times in the day. One is the evening and one is the morning time. These 2 times are called compensation times of the day in which the rate of photosynthesis is equal to the rate of respiration. In the daytime, the rate of photosynthesis is high and the rate of respiration is low. In the night, the rate of respiration is high and the rate of photosynthesis is low. So dear students, in the morning and evening time, the rate of photosynthesis become equal to the rate of respiration. Rate of photosynthesis and rate of respiration are parallel, are equal. In these two times, these are called the compensation times, because the light intensity is not so much in that times, so the rate of photosynthesis is become equal to the rate of respiration. So dear students, the relationship of light with the photosynthesis is a very even if you study if you see the name of the process photosynthesis, the photo is being light, so the light is very important for the photosynthetic process. Without the light, there will be no photosynthesis, because without light there is no light reaction. If there is no light reaction, there is no dark reaction. There is no dark reaction, nothing. So the photosynthesis will never occur in the absence of light. So the light have a very important role. So in the process of photosynthesis. Next is the temperature. Temperature is a very important factor which affects the rate of photosynthesis. It have also directly proportional to the rate of photosynthesis. But dear students, in limits. In limits. If we increase the temperature, the rate of photosynthesis will also increase. Usually 30 to 35 degrees centigrade is thought to be the ideal temperature on which photosynthesis is in its peak. If we exceed from 35 degrees centigrade to 40 degrees centigrade, the rate of photosynthesis will then decrease, and even at 45 degrees centigrade, most of the photosynthetic process ceases. But it is not for, but some plants are exceptional. For example, Cactus Opaltia, which are present in the hot deserts. They can even continue their photosynthetic processes 55 degrees centigrade. But for the mesophytes, mesophytic plants, which are present in, which are terrestrial plants and which are present around us, usually their photosynthesis is in its peak at 30 to 35 degrees centigrade. Dear students, in low temperature, below 10, also the photosynthesis will not happen. Now the question arises in the minds of the students that we know that light is 10 years old, we know that carbon dioxide is 10 years old, so how temperature is affecting the photosynthetic process? Dear students, in photosynthetic process, enzymes work. Mainly the Robisco enzyme I told you in the dark reaction, which initiated the process, which was fixing the carbon dioxide with RUBP. Enzymes which are used in the carbon dioxide are also sensitive to the temperature. So when enzymes used in the direct reaction are temperature sensitive, dear students, the whole process is also temperature sensitive, because if there are no enzymes, how the photosynthetic process will pursue? So temperature have its key role. Third one is the concentration of carbon dioxide. It has also direct relationship concentration of carbon dioxide. If there is low carbon dioxide, there will be low rate of photosynthesis. If there is high concentration of, if there is high rate of high concentration of carbon dioxide, then the rate of photosynthesis will also be high. But again, I will use the word in limits, because if concentration of carbon dioxide increase too much, then it will adversely affect the rate of photosynthesis, because stomata will get open and definitely the rate of photosynthesis will then decrease, because there are many other factors which are also associated with this process. So concentration of carbon dioxide will increase the rate of photosynthesis, but in limits. And if when it will exceed from the limits, then its increase will then negatively affect. It will reduce the rate of the photosynthesis. The final one is the availability of water. So no doubt about it that without water, how we can make the hydrogen for the glucose, and how we will get oxygen. Dear students, water usually play its vital role, because when in the photolysis it is split into oxygen and hydrogen. This oxygen usually combined with another half O2, and it's from O2, and this is that oxygen which is added by the photosynthesis in the atmosphere. Secondly, this hydrogen play a vital role in the formation of NADPH. So water is very, very important for the process of the photosynthesis. Without water, the photosynthetic process is not possible. We can't pursue the process of photosynthesis without without water. Sorry. So this is the importance of water. And if we see the overall duration of the photosynthesis, dear students, this oxygen, which is directly added in the environment, into the environment, then comes from the water. And one CB name was a scientist who who experimentally proved it that the oxygen which is emitted into the environment, which is added to the environment by the photosynthesis, actually the oxygen of the water. This is not the oxygen of the carbon dioxide. He used an isotope of oxygen called O18 here, and then he collected the oxygen which is emitted in the environment, that was O18. And in the carbon dioxide, he used O16 isotope. So in the glucose, he got O16 oxygen. So definitely, the oxygen which is added in the environment by the photosynthetic process is the oxygen of the water. And the splitting of the water in the presence of light is called photolysis, already in the light reaction. So dear students, it was all about the photosynthesis. it is a life dependent process. The entire life process depends upon the photosynthetic process. Without photosynthesis, we can't imagine the life. The life is not possible on the earth in the absence of photosynthesis. Because in the ecosystem, plants are thought to be producers. Why they are plant producers? Because they can produce their own food by the process, and the process by which they can produce their own food is the only process is the photosynthesis, by which there are certain bacteria which are doing another process, chemosynthesis. But photosynthesis is the main driving force of the production of the food by the plants. So it was all about the photosynthesis. In our coming lecture, inshallah, we will explain the respiration process. Thank you so much. And again, if you have any doubts in these processes, mechanisms, you can ask your question in the live session. And I encourage the students, I encourage all of you to ask valid questions regarding the lectures. Thank you so much. Inshallah, see you in the next.